Question is, prove that the roots of the equation this is equal to x are all real. So given this equal to x, so we have to assume that a plus ib is a root, so a minus ib is also a root. Now we'll put this instead of x, so we'll get this, and similarly we have to put a minus ib also instead of x, then we'll get this. So now we'll subtract 2 from 1, then we'll get this, where the bracket part is positive, so b is equal to 0. So imaginary part of the root is 0, so all roots are real. Another question, so solve this using Cardan's methods. Solution, given that this is equal to 0, let x is equal to u plus p. Now cubing both sides, we'll get this. Now comparing x, we'll get this. Comparing the constants and putting the value of u and write y instead of p cube, we'll get this answer. And from u is equal to 6 by p, if p is equal to 2, u will be 3, and if p is equal to 1, so minus 1 plus I root 3, then u will be 3 by 2 minus 1 minus I root 3. And if p is equal to minus 1 minus I by root 3, then u will be 3 by 2 minus 1 plus I root 3. So the value of x will be, we have to add the u and p. So after adding, we'll get the answer this. We'll solve the reciprocal equation now. So given that this equation is equal to 0 and degree of this equation is 4 and even, and this equation is of first type and in standard form. So now from these two we'll take common 6, and from this we'll take 35, so we'll get this. Now we'll divide this equation by x square, so after simplifying we'll get this. Now let t is equal to x plus 1 by x, so squaring this we'll get this. Using this in number 1, so we'll get this equation. After simplifying this, we'll get the value of x minus 3, 1 by 3, and minus 2 minus half. So the roots are minus 3 minus 1 by 3 minus 2 minus half. The question is, solve x to the power 5 minus 4x to the power 4 plus 5x cubed plus 2 square minus 4x plus 5 is equal to 0, and one root is 2 plus I. So solution, given that this equation has one root which is 2 plus I, so another one will be 2 minus I. So if the roots are this, then x minus 2 plus I and x minus 2 minus I will be the factor of the given equation. Now after simplifying we'll get this equation. Now we have to divide the given equation by this. So after dividing we'll get this. After solving the equation, finally got the roots, and the roots are 2 plus I, 2 minus I, minus 1, 1 plus root 3 I by 2, and 1 minus root 3 I by 2. Now the question is solve this equation is equal to 0 if two of the roots are equal in magnitude but opposite in sign. So we have to solve this equation by using relation between roots and coefficient. Solution: given that this equation is equal to 0 and let alpha 1 and alpha 2, alpha 3 are the roots of this equation, where a0 equal to 2, a1 equal to minus 1, a2 equal to minus 18, and a3 equal to 9. So according to the question, the roots are equal in magnitude but opposite in sign. So alpha 1 is equal to minus alpha 2. Using relation between roots and coefficient, we'll get the value of a1. a1 is equal to minus a0 alpha 1 plus alpha 2 plus alpha 3. Now we'll put the values of alpha 1 and alpha 0 in this equation, and in place of alpha 1 we'll write minus alpha 2. So then we'll get the value of alpha 3, and again alpha 2 is equal to a0 minus alpha 1 alpha 2 plus alpha 1 alpha 3 plus alpha 2 alpha 3. Again we have to put the value of a2 and a0. So after putting the value of a2 and a0, and in place of alpha 1 we'll put minus alpha 2, and in place of alpha 3 we'll put half that we get from equation number 2. So after that we'll get the value of alpha 2, a value of alpha 2 as plus minus 3, and in the question we have that two roots are equal in magnitude but opposite in sign. So if alpha 2 is 3, then alpha 1 will be minus 3. So the roots are 3 minus 3 and half. The next question is this: we have to apply Descartes' rule of sign to examine the nature of the roots of this equation. So given this equal to 0, for the positive roots the polynomial is this, and the sign of the coefficients are both positive, and there are no changes in sign in the coefficients of fx, and therefore there are no positive real roots for the equation x to the power 8 plus 1 is equal to 0. And again To find the number of possible negative real roots, we have to evaluate f of minus x. So this equal to this will get this. Here also the signs of the coefficients for f of minus x are both positive. There are no changes in sign, therefore there are no negative real roots for the equation x to the power 8 plus 1. Since there are no positive or negative real roots and f of 0 is equal to 1, so no zero roots, all 8 roots of the polynomial are complex roots.